Welcome to The Explainer. So let's talk about a huge paradox at the heart of AI right now. We have these incredibly powerful assistants, but they can't do one thing that seems, well, pretty simple. Talk to each other. It's like having a team of geniuses who all speak different languages. So what's the secret? What's the key they need to unlock collaboration? That's what we're digging into today.
I mean, it sounds so basic, doesn't it? You've got AIs that can write perfect code, churn through mountains of data, even create mind-blowing art. But what happens when you try to get an agent from Google to work with an agent from OpenAI? Complete shutdown. They just can't. And the reason is surprisingly simple. They literally don't speak the same language.
And this timeline right here, wow, it just lays it all out. Look at the top rows. You see this absolute explosion of LLMs and agent frameworks. It's just packed. But then you look at that third row, agent protocols. See that? It's practically a ghost town until just now. That gap right there is the entire problem. It's the missing piece of the puzzle, the reason all these brilliant AIs are stuck on their own little islands.
Yeah, that gap has basically created an AI Tower of Babel. We built these incredible towering achievements, but none of them can understand each other. They're all shouting in their own digital languages, and nothing gets done on a bigger scale.
And so what you end up with are these isolated islands of incredible power. One agent has no way of tapping into the specialized skills of another agent just because they weren't made by the same company. And look, this isn't just some minor technical issue. It's the single biggest bottleneck holding AI back from solving really big, complex, real-world problems.
But here's the thing. We've seen this movie before. This situation is a dead ringer for the early days of the internet. Remember? Before we had universal standards, the internet was just a messy collection of separate, walled-off networks. Trying to get a message from one to another? Forget about it. It was pure chaos. That is, until a single brilliant idea came along and connected the whole thing.
And that right there brings us to the big idea. We need a TCP/IP, but for AI agents. You know, TCP/IP was that universal language that let any computer talk to any other computer online. Well, these new agent protocols aim to do the exact same thing, but for AI.
So what exactly is an agent protocol? Okay, the easiest way to think about it is as a shared rulebook, a common set of instructions for how to have a conversation. It defines all the basics, how to start a conversation, how to ask for something, how to make sure you understood the reply, and even how to end the chat. It's the fundamental grammar that would let any two AIs talk, no matter who created them.
Now, this agent internet isn't just one simple rule. Nope, it's a whole ecosystem, and it's built in layers, kind of like a cake. At the very bottom, you've got the identity layer. This gives every agent a secure, provable ID. Think of it like a digital passport. Then, in the middle, you have the meta protocol layer. Now, this is really cool. This is where agents can actually negotiate with each other about which protocol or language they should use for a specific job. And then, sitting right on top is the application layer. This has all the specific rules for the tasks themselves, like how to find other agents to work with.
All right, so a whole bunch of these protocols are starting to pop up. And to get our heads around them, we can basically split the field into two big buckets. It all comes down to one simple question. Who is the agent actually talking to?
So on one side, you've got what's called context-oriented protocols. This is all about an agent talking to a thing, a resource, a tool, an API. The analogy here is perfect. It's like an agent using a calculator. It's a simple one-on-one interaction to get a job done. But on the other side, you have inter-agent protocols, and this is where things get interesting. This is about agents talking to other agents. This is way more like putting together a project team where different agents have to collaborate to figure something out.
Okay, that's the theory. But theory is one thing. Let's make it real. To see how these different approaches actually work, we're going to give them a simple, everyday task.
The mission, should they choose to accept it, plan a 5-day trip from Beijing to New York. Super simple request from a human, right? But how the AI system actually goes about doing that, well, that changes completely depending on which protocol it's using. So let's look at 4 different ways this can go down.
Okay, this diagram from the paper breaks it down perfectly. Let's walk through the 4 different philosophies here. First up, you've got the central boss.
In this model, one main agent is the manager. It calls all the different tools itself, flights, hotels, weather, and then it stitches the whole plan together. It's simple, but man, that's a lot of pressure on the boss. Okay, number 2, the office team. Now we're talking. Here you have specialist agents, a flight agent, a hotel agent, and they actually talk directly to each other to coordinate. They work it out amongst themselves. Third, we have the formal partners. Think of this like 2 big companies making a deal. The airline's AI and the hotel's AI interact using these very formal, structured requests. It's all business. And finally, number 4, the translator. This one is super clever. You have a smart layer that takes your normal, plain English request and translates it into the technical code that all the other specialist agents need to get the job done. 4 completely different ways to solve the same problem.
So where does all this lead? What's the big picture? Well, if we can crack this communication problem, we're not just talking about getting slightly better chatbots. We're talking about creating a totally connected, collaborative web of intelligence.
So what does the roadmap look like? Well, short term, the big challenges are making protocols that are flexible enough to evolve and, of course, that protect user privacy. Midterm, the goal is to actually build out those layered architectures we talked about, just like the stack that powers the internet. But the long-term vision, man, that's where it gets really mind-bending. The ultimate goal is to create a true agent data network, a foundational infrastructure, a whole new internet, built for AIs to share, coordinate, and build on each other's work.
And that really is the key takeaway here. This isn't just some small technical fix. Getting this right has the potential to fundamentally reshape what intelligence even means. We could go from having a bunch of isolated smart programs to a genuine distributed collective intelligence, one that is way more powerful than any of its individual parts. It's about amplifying intelligence on a global scale.
So I'll leave you with this question to think about. If we actually pull this off, if we build a true Internet of Agents, what kind of problems could we finally solve? Just imagine specialist AIs from all over the world spontaneously forming teams to tackle things like climate change, or discover new medicines, or respond to a global crisis in real time. The possibilities are, well, they're kind of staggering. And it all begins with one simple thing: teaching them how to talk to each other. Thanks for joining me on The Explainer.